creation of a military tank is a complex process that involves a delicate balance of engineering, technology, and logistics. From the initial design phase to the final deployment, each step is crucial in ensuring the production of a powerful and reliable machine capable of dominating the battlefield. In this exploration, we will delve into the intricacies of tank production, examining the key stages involved: design, material sourcing, assembly, testing, and transport. We will also discuss the role of advanced technologies, such as artificial intelligence and 3D modeling, in shaping the future of tank design. Tank production is not just about assembling parts. It involves a sophisticated interplay of various technologies and skills. This process begins with conceptual design and moves through detailed engineering, testing, and ultimately, assembly. Each stage is crucial for ensuring that the tanks meet the high standards required for modern warfare. Understanding the tank production process reveals the scale and complexity of modern military manufacturing. In this comprehensive exploration, we will delve into how manufacturers produce thousands of tanks each year, examining each phase of the production process in detail. The tank design process is a highly complex and ever-evolving field that reflects the intersection of engineering innovation, military strategy, and advanced technology. As the nature of threats on the battlefield becomes increasingly sophisticated, the demands placed on tank design are also evolving. This dynamic environment requires engineers and military experts to continuously adapt and innovate, using the latest technologies to ensure that tanks remain effective and relevant. One of the most significant technological advancements in tank design is the integration of artificial intelligence, AI, and 3D modeling. AI is a powerful tool that can process vast amounts of data quickly, allowing engineers to simulate a variety of battlefield scenarios and predict how different design choices will perform under pressure. For instance, AI can evaluate the effectiveness of different armor configurations against specific types of munitions, providing valuable insights that help guide design decisions. 3D modeling has also revolutionized the way tanks are designed. Unlike traditional blueprints, which can be challenging to visualize and manipulate, 3D models offer a detailed and interactive representation of the tank. Engineers can explore different design options in real time, making adjustments and refinements as needed. This capability is particularly valuable in the early stages of design, when changes are easier and less expensive to implement. For example, if an engineer identifies that a particular component is too large or too heavy, they can quickly modify the design and observe the impact of that change instantly. The collaboration between military experts and manufacturers is crucial for the success of tank design and production. Military experts provide the strategic context for the design, identifying the critical threats that the tank must be able to counter. Manufacturers, on the other hand, bring their expertise in production processes, ensuring that the designs are not only effective, but also practical to produce. This collaboration ensures that the final product is both technologically advanced and cost-effective. Engineer Jacob from a leading defense contractor emphasizes the importance of this collaboration. Our goal is to create a tank that meets the needs of the battlefield, but we also have to make sure that it's something we can actually build. That's why we work so closely with military experts. They help us understand what the tank needs to do, and we figure out how to make it happen. This balance between innovation and practicality is achieved through close cooperation between all stakeholders involved in the design process. The evolving nature of warfare means that tank designs must be flexible and adaptable. Tanks designed today must not only address current threats, but also be able to adapt to future challenges. Engineers must adopt a forward-thinking approach to design, anticipating future developments in military technology and incorporating that foresight into their designs. This involves using AI and 3D modeling to explore a wide range of possibilities and test them in virtual environments, ensuring that the tanks are not only effective today, but also capable of evolving to meet future demands. With a clear understanding of how modern tanks are designed using advanced technologies, it is essential to consider how manufacturers ensure a consistent supply of high-quality materials. The sourcing and management of these materials are critical for maintaining the production of reliable and effective tanks. Manufacturers face several challenges in this area, including navigating geopolitical tensions and managing complex supply chains. The raw materials used in tank production are as crucial as the design itself. The resilience, durability, and overall performance of a tank depend heavily on the quality of materials such as high-grade steel, advanced composites, and specialized alloys. These materials must meet strict standards to ensure that the tank can withstand the harsh conditions of the battlefield. Sourcing these materials involves navigating a complex web of suppliers and dealing with various geopolitical and logistical challenges. High-quality steel is a fundamental component of a tank's armor. Steel has been a staple in tank manufacturing since the early 20th century, but the steel used today is far more advanced than its predecessors. Modern tanks require steel that is not only strong, but also lightweight, as mobility is as important as protection on the battlefield. This specialized steel, often referred to as ballistic or armor-grade steel, is produced through a highly controlled process that ensures it can absorb and deflect the kinetic energy from projectiles, reducing the risk of penetration. Sourcing high-grade steel involves close collaboration with steel manufacturers specializing in military applications. These manufacturers must adhere to strict quality control measures to ensure that every batch of steel meets the necessary specifications. The steel must undergo rigorous testing, including impact and ballistic tests, to verify its strength and durability. The supply chain for this steel is global, with critical suppliers located in countries like Sweden, Germany, and the United States. However, relying on a global supply chain introduces challenges, particularly when geopolitical tensions arise or trade policies shift, potentially disrupting the steady flow of this crucial material. Advanced composites are another key material used in modern tank production. These composites enhance tank resilience by combining materials to create layered armor systems that offer superior protection. Composites are materials made from two or more constituent materials with different properties, which, when combined, produce a material with characteristics distinct from the individual components. For example, ceramics and polymers can be combined to create a composite that is both lightweight and incredibly tough, capable of withstanding high-impact forces. Sourcing these advanced composites is as complex as sourcing high-grade steel. Manufacturers must find suppliers who can produce materials that meet the specific requirements for tank armor. These suppliers are often at the forefront of material science, developing new composite formulations that offer enhanced performance. Quality control is critical in this process, as any variation in the composition or manufacturing process could compromise the integrity of the armor. The global supply chain for composites includes suppliers across Europe, Asia, and North America, each with its own set of challenges. Specialized alloys are also essential in tank production. These alloys are used in various components, including the engine, suspension system, and weapon systems. They are designed to offer a balance of strength, flexibility, and resistance to wear and corrosion. The alloys used in tank production often contain elements such as titanium, tungsten, and molybdenum, each contributing to the material's overall performance. Sourcing these elements can be challenging due to their limited quantities and fluctuating market prices. The global supply chain for these materials is intricate, involving multiple suppliers and intermediaries. For example, tungsten is primarily sourced from China, which controls a significant portion of the world's supply. This reliance on a single source introduces risks, particularly if geopolitical tensions rise or trade restrictions are imposed. Manufacturers must constantly monitor these risks and develop contingency plans to ensure a continuous supply of materials. In some cases, this might involve stockpiling essential materials or seeking alternative suppliers in other regions. Navigating global supply chain challenges is an ongoing concern for tank manufacturers. The interconnected nature of the modern economy means that disruptions in one part of the world can have far-reaching effects. For example, a natural disaster in a vital supplier region could halt production, leading to delays in tank manufacturing. Similarly, political instability in a country that supplies a critical material could lead to shortages and increased costs. To mitigate these risks, manufacturers often diversify their supply chains, sourcing materials from multiple suppliers across different regions. This approach helps to spread the risk and ensures that if one supplier is unable to deliver, others can step in to fill the gap. Geopolitical issues further complicate the supply chain for tank production. Trade disputes, sanctions, and embargoes can all disrupt the flow of materials, making it difficult for manufacturers to obtain the resources they need. For example, sanctions imposed on a country that produces a key material could force manufacturers to find alternative sources that may be more expensive or of lower quality. Navigating these challenges requires a deep understanding of international relations and the ability to adapt quickly to changing circumstances. Manufacturers also work closely with governments to secure access to essential materials. In some cases, governments may establish strategic reserves of critical materials to ensure that the military can continue to produce tanks even in times of crisis. Additionally, manufacturers may engage in long-term contracts with suppliers to lock in prices and ensure a stable supply of materials over time. These contracts often include clauses that account for potential disruptions, allowing manufacturers to maintain production even in the face of unexpected challenges. With materials sourced and managed, the next critical stage is the assembly of tanks. How do factories integrate automation with skilled labor to produce these complex machines efficiently? The assembly process is a well-orchestrated operation that combines the precision of automation with the expertise of human technicians. Inside the vast factories, where tanks are assembled, the process is both impressive and intricate. Each step in the assembly line is carefully planned and executed to ensure that the tanks are built to withstand the harshest conditions on the battlefield. The assembly process begins with the construction of the chassis, the tank's structural foundation, and progresses through the integration of various systems and components. The chassis is a critical component of the tank, as it supports the vehicle's weight and houses its essential systems. Constructed from high-strength steel, the chassis must be both sturdy and flexible to handle the stresses of combat and rough terrain. Large robotic arms are used to handle and weld the steel plates with precision, ensuring that the chassis is free from weak points or defects. The welding process is carried out in a controlled environment to maintain the highest quality standards. Once the chassis is complete, the powertrain is installed. The powertrain includes the engine, transmission, and drive systems, all of which are essential for the tank's mobility and performance. Modern tanks require powerful engines capable of delivering high levels of torque and horsepower. The installation of these engines involves both automated machinery and skilled technicians. Automated systems handle the heavy lifting and precise placement of engine components, while technicians ensure that the engine is properly aligned and secured. After the powertrain is in place, the suspension and track systems are assembled. The suspension system is responsible for providing stability and shock absorption, allowing the tank to traverse rough and uneven terrain This system includes road wheels, torsion bars, and shock absorbers, each of which must be installed with precision to ensure optimal performance. The tracks, which are crucial for the tank's movement, are then fitted to the suspension system. The tracks must be carefully aligned and tensioned to ensure smooth and reliable operation. With the chassis, powertrain, and suspension in place, the next step is to integrate the tank's electronics and communication systems. Modern tanks are equipped with advanced navigation, targeting, and communication devices that enhance their operational capabilities. The installation of these systems involves careful planning and coordination, as they must be integrated seamlessly with the tank's other components. Automated systems assist with wiring and connections, while technicians ensure that the electronics are properly installed and calibrated. The turret, which houses the main weapon system, is then installed on the tank. The turret must be able to rotate smoothly and align accurately with the tank's targeting systems. Robotic systems position the turret with precision, while technicians secure and calibrate it to ensure that it operates correctly. Additional weapons and defensive systems, such as machine guns and countermeasure systems, are also installed as part of this process. Finally, the tank's armor and protective systems are added. This includes the application of advanced composite armor and the installation of active protection systems designed to intercept and neutralize incoming threats. The installation of these systems involves precise fitting and calibration to ensure that they provide the maximum level of protection. The integration of automation and skilled labor in the tank assembly process is complemented by unique techniques such as additive manufacturing and advanced quality control systems. Additive manufacturing, or 3D printing, allows for the production of complex components that may be difficult or impossible to create using traditional methods. This technology enables engineers to produce custom parts quickly and cost-effectively, enhancing the flexibility of the manufacturing process. Advanced quality control systems play a critical role in ensuring that each tank meets the highest standards of performance and reliability. AI-based quality control systems monitor the assembly process in real time, using sensors and diagnostic tools to detect potential issues before they become problems. This proactive approach helps to maintain the quality and consistency of the final product, reducing the likelihood of defects or failures. Once tanks are assembled, they undergo rigorous testing to ensure their readiness for battle. This testing phase is essential for verifying that the tanks can perform effectively under real-world conditions. Testing includes a range of scenarios designed to simulate the various challenges that tanks might face on the battlefield. Environmental tests expose tanks to extreme weather conditions, such as high temperatures, freezing cold, and high humidity. These tests assess the tank's ability to operate reliably in harsh environments, ensuring that its engine, cooling systems, and electronics can withstand the stresses of extreme weather. Environmental testing is conducted in specialized chambers that can recreate these conditions, providing valuable data on the tank's performance and durability. Stress tests involve live fire exercises, where tanks are subjected to simulated attacks using high-caliber rounds. These tests assess the effectiveness of the tank's armor and defensive systems, identifying any weaknesses or vulnerabilities that need to be addressed. Engineers analyze the results of these tests to make any necessary modifications to the tank's design or armor. Additional tests simulate combat scenarios, such as explosions or chemical attacks, to evaluate the tank's protective systems. These tests help to ensure that the tank's armor and countermeasures can provide adequate protection against a range of threats. The results of these tests inform further improvements to the tank's design and capabilities. Quality control is a critical aspect of the testing process. Engineers use diagnostic tools and sensors to monitor the tank's performance, analyzing data to identify potential issues and make adjustments as needed. This iterative process helps to ensure that the final tank is robust, reliable, and capable of performing effectively in combat. With the testing phase complete, the tanks are prepared for transport to military units around the world. Transporting tanks involves a series of logistical challenges, including disassembly, loading, and securing the tanks for transit. For road transport, tanks are loaded onto flatbed trucks, requiring special permits and careful planning. The weight and size of the tanks necessitate the use of specialized equipment and routes, ensuring that the tanks can be transported safely and efficiently. Road transport is typically used for domestic deliveries or shorter distances within a continent. Rail transport is another method used for moving tanks over long distances within continents. Tanks are loaded onto rail cars, which are equipped to handle the weight and size of the tanks. Rail transport offers a cost-effective solution for transporting tanks over large distances, though it requires careful coordination with rail operators and infrastructure. Sea transport is commonly used for international distribution, with tanks being loaded onto cargo ships for transport across oceans. Sea transport involves securing the tanks to prevent movement during transit, using specialized equipment and techniques to ensure their safety. This method is often used for bulk deliveries or when transporting tanks to distant regions. Air transport, while more expensive, is used for urgent deliveries or when tanks need to be deployed quickly. Cargo planes capable of handling the size and weight of tanks are used to transport them to their destination. Air transport requires meticulous planning and coordination, including the use of specialized equipment to load and unload the tanks. Each transport method presents its own set of challenges and requires specialized equipment and coordination to ensure the safe delivery of tanks. Manufacturers and transport agencies work together to address these challenges, developing solutions to minimize risks and ensure that tanks arrive at their destinations in optimal condition. Once the tanks arrive at their destination, they are unloaded, reassembled if necessary, and undergo further inspections before being distributed to military units. This final stage ensures that the tanks are fully operational and ready for use, completing the complex journey from production to deployment. In summary, the production of military tanks involves a multifaceted process that blends advanced technology, skilled craftsmanship, and efficient logistics. From design to assembly, each stage plays a critical role in ensuring that tanks are capable of meeting the demands of modern warfare. The integration of AI and 3D modeling and design, the careful sourcing and management of materials, the sophisticated assembly process, and the rigorous testing and transport all contribute to the successful production of these powerful machines. Understanding the complexity of tank production provides insight into the incredible effort required to maintain a modern military. The continuous evolution of technology and the challenges of global supply chains underscore the importance of innovation and adaptability in ensuring that tanks remain effective and reliable in the face of ever-changing threats. The production of military tanks is a testament to human ingenuity and engineering prowess. From the meticulous design process to the rigorous testing and deployment, each stage of the process is essential in creating a machine capable of meeting the demands of modern warfare. Let us know your thoughts in the comments, and please don't forget to like, share, and subscribe.